Hi class, today I will show you a tutorial for practical seeds, that is normal distribution. Alright, let's see the first questions. The first question says that x is a normally distributed variable with mean or mu equal to 30 and standard deviation or sigma equal to 4. So find A, for question 1A, find P, that is x less than 40. Alright, if you remember in our previous lecture class, or if you refer to lecture notes 2B, continuous distribution, you can see that the formula in normal distribution is referred to Z equal to x minus mu divided by sigma. So x is the value that have been given, mu is referred to the value of mean, and sigma here is referred to the value of standard deviation. So in this practical, we are going to use this formula because it refers to the normal distribution. So how to get P, that is x less than 40. So P, that is x less than 40, so we can convert into this formula to get the value of z. So z equal to x is referred to 40. So 40 minus mu. So in question 1a, the mean or mu that have been given is referred to 30. Divide by sigma. So the sigma value or standard deviation is referred to 4. So when you calculate this value, you will get z is equal to 2.5. So P x less than 40 is equal to P z value that is less than what we get here, 2.5. So Px less than 40 is equal to Pz less than 2.5. Okay, so how to get the z value that is less than 2.5? So if you draw the graph, for example, here, 2.5 maybe around here. So now, the questions wants you to get the value of z that is less than 2.5. So less than 2.5 should be to the left area here. So what is the value of Z that is less than 2.5? So how to get this value? So you can refer to the standard normal distribution table. Remember again, in standard normal distribution table, it will give you the Z value that is to the left. So these questions also want you to get the Z value to the left, that is Z less than 2.5. That is around here. So what is the Z value to the left area? This area. So if you refer to the standard normal distribution table for 2.5, you will get 0.99338. Okay, so the value here is, the Z value here is 0.9938. Okay, so in your practical task, you can choose either you want to draw this graph or not. It is not compulsory to draw this graph. I'll just show you to make sure you understand it. But in your task, the important part is you show the formula and then how you convert the value into the formula and what is the Z value that you get. And when you refer to the standard normal distribution table, what is the final answer or the final result that you will get. Okay, so let's proceed to the next questions. Okay, in 1B, the question wants you to find P that is X greater than 21. If in 1A, the question wants you to get the value that is less than. And now in 1B, the questions want you to get the value of X that is greater than 21. Again, when you refer to the formula for normal distribution, Z is equal to X minus mu divided by sigma. So now, X value here is 21. And the mean or mu that have been given is 30. And sigma or standard deviation that have been given is 4. So when you calculate this value, you will get the Z value is equal to negative 2.25. All right, if you draw the graph, because the Z value is negative, so it must be something around here, negative 2.25. But now the questions want you to get the value that is greater than 21. That is Z, the Z value P X greater than 21 is equal to P Z is greater than negative 2.25. Okay, because now Z is greater than, so greater than should be approaching to the right. So the question wants you to get the value in here, the right area. But first of all, never mind, we find the left value first, that is in this area. We find the left value first because the standard normal distribution table will give you only the left area. So when you refer to the standard normal distribution table, you will get the value for negative 2.25 is referred to 0.0122. However, the question wants you to get the value of Z that is greater than negative 2.25. That is here, the right value. So how to get the right value? So area under the curve is equal to 1. So to get the area of right, the value in right area, so area under the curve or the total area, the total area that is area under the curve that is also equal to 1 minus that is area to the left. Area to the left. Okay. So to get the value in the right area here, you need to get the total value or total area under the curve, that is 1 divided by area to the left, that is 0.0122. Then you will get 0.9878. So what is the value, the Z value that is greater than negative 2.25? So it is 0.9878. Okay. Now let's see for 1C. For 1C, okay, the question wants you to get the P value that is X in between 30 and 35. Okay. So when you convert into the formula of P, remember again, the formula to get the Z score is X minus mu divided by sigma. So now, X value is 30. So now, let's say P, this is P that is 30. X value here is 30 divided by, what is the value of mean? Okay, you convert into this formula. Okay, so 30 minus mu that have been given is 30. Okay, 30 and divide by sigma, that is 4 less than X less than 35. Here, this one, 35. Okay, minus mean, that is also 30. And divide by sigma, that is 4. So when you calculate this value, you will get P that is 0 less than X less than 1.25. All right. If you want to see where is the area in the graph, you can draw the graph. Okay. So the Z value here we get is, this is Z value. Okay. Z value, because we have already converted into this formula, this value, this both value, we have converted into the Z value formula. So we'll get 0 less than Z less than 1.25. All right. In the graph, so when Z is greater than 0 and less than 1.25, it usually be something around here. So 0 and 1.25. 1.25. So this is the value, the Z area. So the Z area here is P 0 less than Z less than 1.25. Okay. So what is the Z value here? That is between 0 and 1.25. So when you want to get the value, here, the area to the left of the Z, area to the left of Z, this is the area to the left of Z, the value of Z, the value at the left here, this one, at this area, okay, that is 1.25. So area to the left of Z, that is equal to 1.25, okay, should be minus area to the left of 0, this one. So area to the left, and when you refer to the graph here, all right, how to get this, the value in this area? So you need to get the area to the left of Z, right? Area to the left of Z, that is 1.5. Here, that is the left to the Z 1.5 minus by area to the area to the left of, to the right of 0, this one. So 0. So area to the left 1.25 should minus by area to the left of 0. So if you refer to the standard normal distribution table for Z value that is for the value that is 1.25, you will get the value of Z area that is 0.8944. So equal to area to the left of Z that is equal to 0 in standard normal distribution table, you will get 0.5. So the final answer is 0.3944. So what is the Z value that is between 0 and 1.25? It's here. So it is 0. The value here, or the area here, is 0.3944. Okay, so again, I want to remind you that it is not compulsory, it is not a must, all right, not a must to draw this graph. I only draw this graph because I want to make you more clear how we get the Z value. Okay, so in your task, in your practical task, the important step is first you show what are the formula that you use and how you convert into the value into the formula, and then what is the value of Z that that you get, and then when you refer to the standard normal distribution table, what is the value that you get, and also what is the final answer. Okay. All right. I will show you another ways how to get the calculations for question number 2 and maybe number 3 and number 4. But for question number 5, 6, and 7, please discuss in your group, in your practical group, all right? And please complete all the questions. Okay. All right, let's see. There is another examples for question number 2. All right, please refer to your practical questions, the question number 2. Let's read together. All right, for question number 2, a radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 km per hour and a standard deviation of 10 km per hour. What is the probability that a car picked at random is traveling at more than 100 km per hour? Remember, as I usually mention to you, when you get a questions, you need to recognize the important point. And you need also to pick the important point out first. Okay, so for question number 2, when you refer to the questions, all right, the speeds in the second sentences, the speeds are normally distributed. So normally distributed is the first key point. So it refers to the normal distributions calculation of formula. All right, and then with a mean of 90 km per hour. So they give you the value of mean or mu is equal to 90. All right, and the question said a standard deviation of 10 km per hour. So the standard deviation or sigma is equal to 10. What is another point that we got here? And all right, if you refer carefully to the questions, so we are going to say that let x be the random variable that represent the speed of cars. So another key point here is let x be the random variable that represent the speed of cars. So this is the first point that you pick it out. Second point, and the third point is let x be the random variable that represent the speed of cars. Okay. And then what is the question said? The question said is, what is the probability that a car picked at random is traveling at more than 100 km? So more than 100 km. So the next key point here is P, that is S, is more than 100 km per hour. So the question wants you to get the probability that a car picked at random is more than 100 km per hour. So more than is referred to greater than. So P is S is greater than or more than 100. So again, when the question is referred to normal distribution, so you must refer to the standard normal distribution formula, that is Z mu minus, that is S minus mu divided by sigma. So when you convert into the formula, X is equal to 100 minus, that is this one, the formula. Okay, X is 100 minus mu. So the mu here is 90. So 100 minus 90 and divide by sigma that have been given here is 10. So when you calculate the value, you will get the Z value is equal to 1. So P that is X greater than 100 is equal to P Z greater than 1. Okay. Again, when the question wants you to find more than or greater than, that means it refers to area to the right. Okay, refer area to the right. So, how to get the area to the right? So, total area, again, total area, this is total area. Okay, I'm not write the full sentence here, but in your practical task, please write the full sentence. That is total area. Okay, so total area minus area to the left of Z that is equal to 1. So please also write the full sentence. That is area to the left of Z that is equal to 1. Okay, so please write the full sentence in your practical task. That is the total area minus area to the left of Z equal to 1. Okay, so that the total area under the curve is equal to 1 minus what is the area to the left of Z that is equal to 1. So to get area to the left of Z that equal to 1, you must refer to the standard normal distribution table. So when you refer to the standard normal distribution table for the area to the left of Z that is equal to 1, you will get 0.8413. So 1 minus 0.8413, you will get 0.1587. So you will get 1 minus 0.8413 is 0.1587. Okay, so the final conclusions based on this question or on these questions, okay, this is not the final answer, all right, it's not the final answer yet, although you get the value is correct. Please insert in your task, all right, that the final answer is the probability that a car selected at a random has a speed greater than 100 km per hour is equal to 0.1587. All right, I repeat again. In your final answer, after you get the value 0.1587, please state it also that the probability, all right, the probability that a car selected at a random has a speed greater than 100 km per hour is equal to 0.1587. Okay. All right, let's proceed to question 3. All right, in question 3, let's read the question together. For a certain type of computers, the length of time between charges of the battery is normally distributed with a mean of 15 hours and a standard deviation of 15 hours. John owns one of these computers and wants to know the probability that the length of time will be between 50 and 70 hours. All right, let's find first what is the main point in these questions. All right, if you read the first sentence, right, the length of the time between charges of the battery is normally distributed. So the first key point here is normally distributed. So it must refer to the normal distribution calculations. Okay, and then the question stated that with a mean of 50 hours. So the mean or mu is 50 hours. And a standard deviation is equal to 15 hours. Okay. And what is the next point that you need to pick it out first? Okay. So the next is let x be, okay, let x be the random variable that represent the length of time. Okay, please write the full sentence when you pick all the main points out from the questions. Okay, so let x be the random variable that represents the length of time. All right. What are another points here? So, what is the question wants? All right, the question wants you to find, okay, the probability that the length of time will be between 50 and 70 hours. So P is X is in between 50 and 70 hours. All right, again, when you refer to the normal distribution formula, how to get the Z? So Z is equal to X minus mu divided by sigma. So when you insert the value into the normal distribution formula, so here the X is 50, so 50 minus mu that have been given here is 50. So 50 minus 50 divided by sigma. So sigma that have been given is 50. And Z here. So the second one is 70 hours. So X is equal to 70 minus mu is 50 divided by sigma that is 15. So when you calculate the value, you will get P is Z. 0, Z is in between 0 and 1.33. Okay. So it seems like the question 1C. Right? So when you want to get the value of P that is Z in between 0 and 1.33, okay, area to the left of Z that is equal to 1.33, right, this value minus the 0 value. Okay, so you need to state it here is area to the left of Z, right? Area to the left of Z, area to the left of Z equal to 1.33 minus area to the left of Z equal to 0. All right, here I just write the short form, okay? But in your task assignment, please write the full sentence, okay? Please write the full sentence. So the sentence is area to the left of Z equal to 1.33 minus area to the left of Z equal to 0. So area, what is area to the left of Z equal to 1.33? So when you refer to the standard normal distribution table, you will get 0.908 minus, all right, area to the left of Z equal to 0. So when you refer to standard normal distribution table, 0 is equal to 0.5. So this value, both this value refer to standard normal distribution table. Okay. So we'll get the answer is 0.4082. So what can you state in your final answer when you got 0.4082? So you must state that the probability that John's computer has a length of time between 50 to 70 hours is equal to 0.4082. Again, I repeat, the probability that John's computer has a length of time between 50 to 70 hours is equal to 0.4082. So that is your final answer. Okay, so let's see for questions number 4. Okay, for questions number 4, let's read the questions together. Entry to a certain university is determined by a national test. The scores on this test are normally distributed with a mean of 500 and a standard deviation of 100. Tom wants to be admitted to this university and he knows that he must score better than at least 70% of the students who took the test. Tom takes the test and scores 585. Will he be admitted to this university? Okay, let's find the important points in this question. If you refer to the second sentences that stated, the scores on this test are normally distributed. So the first key point here is normal distribution. And the question said with a mean of 500. So mean, that is mu, is equal to 500. And a standard deviation, or sigma, is equal to 100. Okay. So what is another main point here? So let, please write the full sentence. Okay. So let x be the random variable that represent the scores. Okay. Let x be the random variable that represent the scores. Okay. And the next key point here is the total area okay, please write the full sentence. The total area under the normal curve represents that the total number of students who took the test. Again, the total area under the normal curve represents the total number of students who took the test. Okay. All right, the question also said that Tom takes the test and scores 585. Okay. So P is S equal to 585. Where we get the value of X that is equal to 585. So when you refer to the questions, it says that Tom takes the test and scores 585. So again, you need to refer to the normal distribution formula, that is x minus mu divided by sigma. So here let's see how to get z. So the value of x is 585. So 585 minus this one, mu, and divide by sigma. So the mu that have been given is 500. Divide by sigma that have been given is 100. Okay. So when you calculate the value, you will get B z is equal to 0.85. Okay. So the proportion of the students who scores below 585 is given by P equal to area to the left of the Z, that is equal to 0.85. Okay, so when you refer to the standard normal distribution table, you will get E is equal to 0.8023. Where we get the value of 0.8023? All right, we get when we refer to standard normal distribution table that provide the area to the left of Z equal to 0.85. Okay, area to the left of Z that is equal to 0.85. So you will get 0.8023. All right, in these questions, it stated that Tom wants to be admitted to this university and he knows that he must score better than at least 70% of the students who took the test. So we must find the value in percent to determine either Tom can admit to the university or not. So if we multiply the value of the areas under the curve by 100, we obtain the percentage is 0. That is 0, this one, 0.8023, right? When you multiply the value of the area under the curve by 100, so you will get the percentage is 80.23. Okay, that is 80.23. Okay, you can multiply with 100 to get the percentage. So when you multiply with 100, okay, this one. So you will get 80.23. So 80.23%. So now when we get the answer is 0.23, will Tom will be admitted to the university or not? So the final answer here is Tom score better than 80.23% of the students who took the test. So Tom will be admitted to this university. So you must state it here. Tom, okay, Tom score better than 80.23% of the students who took the test. So Tom will be admitted to this university. Okay. Again, the final answer is Tom scored better than 80.23% of the students who took the test. So, Tom will be admitted to this university. Okay. Okay, class. So, that's all for tutorial practical 6. That is normal distributions. Please discuss with your member groups to get the answer for question number 5, 6, and 7. All right, please complete these assignments and submit to me through Putra Blast. So because this is the group task, so I will not accept the individual submission. So the submission that must be submit through Putra Blast must have 14 submission. That is equal to 14 groups. That is not more than 14 or less than 14. Okay, if you find difficulties to show the equations or to answer this practical in Microsoft Words, all right, so you can write in a paper, right? Write in a paper, write in a clear, all right? So write in the paper, then you snap the photo or the picture of the equation that you write in the paper, and then you attach in words or attach in other appropriate methods. All right. Then after you complete, you submit through Putra Blast. Okay, class? If you have any questions, please do ask me. Okay, so that's all for now. Thank you and all the best.